Hello everyone, welcome back. In this video we will be learning about variables in mechanical ventilation which are fundamental for understanding the ventilatory waveforms and the modes of ventilation. To understand variables, we need to appreciate that respiration is a dynamic process in which pressure, volume and flow are functions of time. In other words, they change over time. These changing entities in the ventilator are called variables. Let's begin by analyzing this waveform generated by mechanical ventilator. The waveform on the left is pressure time scalar, and on the left is flow time scalar. Mechanically generated breath has one cycle of positive breath or inspiration, and one negative or expiration. There are four distinct points in breathing, namely, beginning of inspiration, end of inspiration, beginning of expiration and end of expiration. As you can see, the pressure and the flow continuously changes during different phases of the breathing. Now let's get back to the variables. There are two kinds of variables, control variables and phase variables. The control variable is the parameter which the ventilator uses as the feedback signal for controlling inspiration. Pressure, flow and volume are all possible control variables, but conventionally only pressure and volume are used. Control variables in mechanical ventilation are independent parameters which are targeted by the ventilator mechanism, and upon which all other variables are dependent. The word control here implies that the person setting the ventilator is most interested in that specific variable, and wants to control that variable exclusively, that is, without letting the respiratory system make any decisions about it. You might have heard about pressure control and volume control, where the clinician focuses on achieving targeted volume or the pressure by setting it on the ventilator. Phase variables in mechanical ventilation are parameters which control the phases of a mechanical breath, that is, starting and ending inspiration and expiration. A mechanical breath has four distinct phases, each of which has a governing variable which determines how that phase proceeds. For the ease, I will use the pressure time scalar for explaining the phases of mechanical breath. The four phases are initiation phase controlled by the trigger variable, inspiratory phase, controlled by the limit variable, cycling phase, controlled by the cycle variable, and expiratory phase, governed by the PEEP variable. The initiation phase starts at the end of expiration. At this stage, the breath is triggered or initiated either by the machine or by the patient. The trigger variable controls how this occurs. The most common trigger variable settings are time, flow, and pressure. Inspiratory phase begins once the breath is triggered and the inspiratory flow begins. This phase is defined by airflow into the patient. The limit variable controls this phase by setting limits by using either pressure, flow, or volume parameters. In other words, limit variable basically controls the extent of inspiration. Cycling phase describes the brief instant during which airflow has ceased and expiration is about to begin. This phase is controlled by the cycling variable, which determines how and when the ventilator cycles from inspiration to expiration. Typical settings include time cycling, flow cycling, and pressure cycling. Expiratory phase begins when the ventilator cycles from inspiration to expiration, during which the expiratory valve opens, and the patient exhales passively. This phase is defined by airflow out of the patient. This phase is controlled by the PEEP variable. PEEP is the pressure which remains after expiratory airflow has stopped.